What's up, my guys? How's it going, everyone? Starting off the stream nice and easy. This is a bit of a weird one. I think they have put this in the wrong box. Let's check for audio. Sean Barlow, what's up, man? You was watching the B2 Riot 16K video. I've done a couple of those. Which one was that you were watching? Was that the one where I was doing a bunch of streams, fixing the output sections, etc. Yeah, this is fine. Nice clean sine wave, nice clean sine wave. Let's check the other filter modes. Okay, it seems this one comes in and out a little bit here. How's it going, everyone? Oh, the Christmas ones, yeah. That was when I was working on the output sections. One's from Denmark. What's your least favorite amplifier lines to repair? Yeah, the Rockfords can be a massive pain in the arse. Although I think for me, it's either got to be Alpines that have really complicated faults because they are really complicated to repair, or it's just really massive Korean half bridge amps, like yeah, 12K stuff. So this is a bit of a weird one. This amp works sometimes. A bit of DC offset now on the output terminal there. Okay, more DC offset when I increase the bass boost. Ah, hang on a minute, I'm zoomed in too far. That might help if I unzoom a little bit. Okay, so we only have output on one of the channels at the moment on this one. Possibly a dirty potentiometer. Nope. Possibly is a preamp issue. Good old Vibe Monobox 4. Jason's just picked up one of those. Yeah, man, they go back a fair while. Not seen one of those in a while. Okay. What's with this then? I had audio a minute ago on both channels. Now I don't, so that's got to be something intermittent connector, connection somewhere. But no matter how much I wiggle doesn't seem to matter. Have you ever commented on why most Brazilian amps don't have bass knobs? I don't know, honestly. I don't know why Tower amps just don't bloody include one, for example, or Sound Digital. It would make so much sense. Everyone's crying for one. Why don't they just include a bass knob? Well, I think Tower amps have now started to include a bass knob. They actually include one with the Smart 8, or you can buy it separately or something. But yeah, it's a bit of a weird one how they don't seem to want to include bass knobs from back in the day. Here we go. Okay, so it is definitely some kind of vibration-y type issue, bad solder joint, because as I tap this we do get a spike on the scope screen here. Just not sure where the bad connection is exactly. Just got to try and find it. It's probably, I think it's, here we go, preamp related. If I tap here we get a bit of a sine wave. Doesn't seem to be the switch. And I'm on full range mode, so I wouldn't have thought the low pass or high pass filters would make a difference here. That's off. The gain potentiometer, it doesn't seem to make a difference either. Let's just check these high pass, low pass filters anyway, even though we're set to full range, just in case it goes through the potentiometer still. No, so neither of those makes a difference. So it must be somewhere before the drive circuit of the. There we go. There we go. We have a sine wave now, and if I tap again, probably go away. Yeah, so we just got a bad solder joint somewhere on the back of this PCB. This one is a bit of a liar. So I've just picked out this amplifier to look at, and this one says no. It says no output faulty, set fire, but I'm honestly not seeing any signs of fire in this one. So unless we find something horrendous underneath the board when we take the board out, that seems to be a bit of a fib. Just going to take my jumper off. It's got a little warm this evening. What's good, buddy? How's it going? How is everyone's weekend going so far? Tell me what you've been up to. How's it going, Sergio? Sergio? Evening Jukebox, what's up? It's rainy AF. Yeah, it's absolutely torrential here as well. Like literally the last week has just not stopped raining. This is a piece of junk. Well, no, sorry. This is not. This amplifier is a pretty budget entry-level amplifier, and so there's not a lot of guts inside here. It's just a very nice, easy, basic class AB that we're looking at here. How's it going, Mike Honda? Good to see you, buddy, as always. So, do we have any remnants of fire on the bottom? No. So, this was a lie. Maybe they got them mixed up. This one hasn't set fire. So, although actually, I don't know. There's something funky going on over here by the what looks like possibly the high level inputs location of the board here. So, see here, there would normally be high level inputs. But it's not used on this amplifier. But if we take a look on the back of the PCB, there definitely has been some kind of something happen over here. Or maybe not, I don't know. No, I think that's just like a bit of black rubber. It's not actually soot. Okay, so no, that's fine. So what we're looking for is some... Ah, hang on a minute. There we go. What? Have a look at this, guys. Have a look at this. So you see this capacitor. Okay. This is an amplifier from factory, okay? This is from factory. Wow. I guess that one just got missed. Hot dang. Okay, let's solder that. Crazy stuff. And I'm pretty much guaranteed that's all that the issue is. I think that's a DC blocking cap for the sending the signal to the drive circuit for the output section. Oh yeah, hey, check this out. Check this out. Oh! QC passed, my guys. It's fine. It's fine. That's absolutely fine. No, don't even worry about it. This capacitor, it doesn't need to be soldered. It's just going to rest there on the pins, and yeah, it doesn't matter. It's fine. There's no worries, guys. Alright, let's just confirm. You know what? I'm actually so confident. I'm actually so confident. I'm just going to shove it back in the case for a sec. There we go. Let's just check for audio on both channels now then, shall we? Evening Brendan, how's it going, man? Long live the legend. I wouldn't really say that, but thank you. Trying my best. Alright, what are we saying? There we go, a bit of audio on this channel, which we was missing it on before. Just double check that giving the board a tap doesn't make it disappear. Nope. And check the other channel. Yep, cool. So that's all it was. Cheeky capacitor got missed in factory, hey? Well, how's about that then? Stefan says, probably some hand job there in the factory. I mean, where do I send my CV? Oh, John, man, thanks for the 10, my man. Appreciate that, dude. If you've got a question or anything you want to say, just give me a shout, man. Really appreciate that 10, buddy. That's really cool of you. Hope you're having a good day, my man. Hello, quad feed. Hello. Hello, hello, hello. Are you going to replace the thermal paste? Nah. It's got enough on it from factory. We haven't replaced any components, any parts, so the thermal paste that's sitting on the back of the MOSFETs will be in the pits and grooves of the MOSFETs and transistors already, where it needs to be. Honestly, the cost price on this amplifier, right? The cost price on this amplifier is probably about $4. So no, I'm not wasting my time putting more thermal paste on. This thing actually isn't worth repair. The only reason that I'm repairing this is because I'm doing some analysis stuff for this company to try and reduce their warranty returns. So basically they've asked me to check out all of their warranty returns, tell me what's wrong with them, and then suggest changes be made, like, you know, to the assembly of these or the circuit designs or whatever, to improve them to prevent as many warranty returns. Not that they get a huge amount anyway, but just to, you know, minimize warranty returns. I don't even know if this amplifier will be sold on or not. No idea. So far, from everything that I've seen, is I mean, this is a very budget amplifier, so the circuit is fine. This is designed just to beef up your power to your door speakers more so than your head unit can deliver. It's going to sound fine. But the biggest issues that I've seen so far, the circuits are fine in like the bass amplifiers, the Class D bass amps. It's an older circuit design, but it's very good value for money. But the main issue is build quality. Most of the amplifiers have vibration damage. And there are some circuit oversights as well, but none of them that have really super led to the amplifier failing. Literally most of it has been just vibration damage. So got another little QC sticker on the back here as well. Love to see it. Thanks Marius for the $4.99. Appreciate that, my dude. Hope you're good. Any ideas to a ground zero 8K having 3 volts DC on the speaker terminals at all times, flashing in power LED and protect LED? What type of ground zero 8K is this? Is this one of these sound digital clones? The GZHC? No, sorry, not the GZHC. The ground zero. What is it? I can't remember the model numbers that they've used now, but if it's one of the newer full bridge ones that's a sound digital clone, then yeah, there's either dead output FETs or there's something wrong with the drive circuitry. It depends whether it builds rail voltage or not. If it's an older Korean board, that's very unusual because they have a relay isolating the output section and the speaker terminals, so you shouldn't get any DC offset at all on the speaker terminals before the relay clicks in. If you do, I'm trying to think where it would come from, because that circuit isn't really connected to anything. Although the only thing that circuit's connected to, that the speaker terminals are connected to when the relay is not engaged, is it's connected to a little circuit that detects DC offset. Now if that DC offset detection circuit is faulty and has damaged, then it could be sending some DC from its supply voltage to the speaker terminals. So that could be something to look into. It's a GZCA. Okay, so it's a Brazilian. Yeah, in that case it could be like all sorts of issues. It depends if it builds rail voltage or not. So you need to crack the back open, see if it's building any rail voltage or not before it protects. It's probably got dead output FETs though, to be honest. Thanks very much, Brandon. Appreciate the compliment there, my guy. Thank you. Hello, Shannon. How's it going? What would be the reason for that? The output filter inductor of Class D amplifier heat up very quickly, even without signal. So the output inductors will always heat up because the output inductor is doing work. It is filtering the high frequency Class D switch wave from getting to the speaker terminals. And depending on how well the amplifier has been designed, and how optimized the inductor values and the capacitor values are in that network, will depend on how hot the inductor gets. But it's perfectly normal operation, and yeah, it can feel quite hot to the touch, and that's pretty normal. If the film capacitor that sits after the inductor is faulty and it has shifted in its value, then that could cause the inductor to run hotter than it should. So if you're not sure, maybe pull the capacitor, check it on an ESR meter like this. But the capacitor is probably fine. But that's just pretty normal, to be honest. Thanks for the 10, my man, Mike Honda. Appreciate that, dude. I hope you're doing well. You're always very generous. What would you do as for charging a 189 volt DC system? Hey, oh, I see. So me and Eberg was wondering, Taramps high voltage 20k in series, a bunch of batteries. Yeah, it's a difficult one, that. Yeah, how would you charge this? I know obviously people do, but if I'm perfectly honest, there's kind of no point running a HV20k because, well, I mean, there is. I would only run a high voltage amplifier like that, firstly, if I was extremely brave and I had taken all the precautions, and you know, I had the skills and the workshop area and everything, and some helping hands as well. And I was doing that build in an EV that already had high voltage battery system, charging system, etc. For putting this in a regular vehicle with a 12-volt charging system, just get a base 15k, or just get a Powerus PW 15k. They already make like 18,000 watts at 14 volts, so that's pretty much near to the 20k anyway. So yeah, just do that. It's much safer and much easier. I know that there are benefits obviously to having the rail voltage be the batteries, but then charging it is not super simple. You might have to make your own charger for it or something, or I don't know. Maybe see if an EV charger has that kind of charge voltage. No idea. Haven't really thought about it before. How's the LTT screwdriver holding up over time? Well, naturally, because I was gifted this one. I was gifted the one with the black shaft, and the black shaft is definitely getting scratched, as Linus said it would. He didn't want to do the black shaft model, but lots of the community wanted a black one, so he made one, and this is the one that I got gifted. So as you can see, yeah, the black shaft gets scratched and ruined, but the actual screwdriver itself, the mechanics of the screwdriver and how it looks, yes, great. Doing nicely. One of the main things that I love about the LTT screwdriver, to be honest, is the strength of the magnet. It's mega strong. I love that. Really, really handy. Alright, what's going on in this one then? The sticker on this one says faulty output. So I assume we've got an output section fault. Maybe it's not producing a sine wave. Maybe it's in protect. Let's have a look. So first of all, check for shorted output fetch. This is a British standard. It's a 2092 driver, going to be running a bunch of 640Ns, I imagine. So no shorted output FETs. Let's have a little visual check for vibration damage on these legs. They tend to have little orange spots. Oh, this rail capacitor has been soldered very high. I don't know how well this will come out on the camera. But basically there's a huge gap under this rail capacitor right here. You can see by how much that's wobbling there. Massive gap. It does feel soldered on both legs, but that's pretty crazy. Not really very optimal for, you know, surviving heavy vibrations that might snap at some point. I don't know if I've got it in me to take the whole board out just to resolder that if there's nothing wrong with this though. Given that I don't even know if these amps are going to be used again or not, because these are warranty returns that I'm just doing analysis on. It says faulty output on it. Okay, let's plug in some power wires and see what it's doing. Mike says, I was thinking of a 180 volt pulley driven generator spun by a 12 volt electric motor. That's a lot of terribly inefficient energy conversions going on there. Why not just spin the generator with the engine's rotation? Like, have some kind of pulley system off of the auxiliary belt, setup to spin it. You don't spin it with a motor. That's just like efficiency, just going down the drain. You're just using power to create heat and noise and shit for no reason. Oh, but you're talking about charging it. Sorry. Yeah, well, you could charge it in the vehicle if you did it by that. You could have it charged in the vehicle if you could find some kind of generator / alternator type of thing that you could spin like an alternator in the vehicle. Then obviously you can charge it while you're driving like a regular alternator you would. Okay, let's power this up and check we've got Class D switching to start with. Let's give it a little bit of rail voltage to start with. Okay, a couple of pulses there. So that's our positive rail there. Zoom in a bit on the scope and should have our negative rail over here. Yep, so we should get Class D switching appearing here at some point. When the relay clicks in, probably, because the load resistor will be after the relay. Oh, okay. So this one doesn't want to build Class D switching. It's trying very, very hard, but not actually managing to do so. As you can see by this scope screen here, this is what it looks like when Class D switching is trying to build, but is not able to do so. And the reasons for this can be a number of things. I'm just going to give the board a few little taps just to see if it's something vibration damage related, dodgy connection somewhere possibly. Also going up to 12 volts, that doesn't make a difference either. Yeah, this. So the issue that this is showing me is often to do with either a bad drive IC, a faulty 2092 can cause this, or the 2092 is not getting any supply for high side bootstrap, so the bootstrap diode could be bad, or a resistor that leads from the low side drain to the high side supply bootstrap circuit is open or not soldered properly or something like that. One thing that we can do is sometimes amplifiers like this just need a kickstart. They can be doing that and glitching and trying to power up, trying to self-oscillate, but they actually just need a little bit of signal to get themselves kick-started, or a load on the terminals. So I'm just going to inject a little bit of signal and see what that looks like. If it still fails to build even with a bit of signal, then we know that it's like something wrong with the drive circuit here. So bought your eBay listing for Amplifier. Are you still doing eBay send-ins? Yes, absolutely, my man. If you bought the eBay listing, you just need to send me a message with the amplifier make and model. Like in the listing, my eBay listing, it states quite clearly. So all you got to do is just, if you want to buy the listing, buy it, send me a message with the make and model and fault you're experiencing. Then I'll get back to you, and then we go from there. So let's see whether injecting a signal helps this to self-oscillate or not. I imagine probably not. Okay, yeah, no. So injecting a signal, we still get the same glitching, but we're actually getting a swing to negative rail. So that shows me that, yeah, either fault with the 2092 or issue with the high side bootstrap supply. So let's just have a look at the output driver card here. This is kind of bent over at a funny angle. I would usually be able to work on the drive circuit without having to take the board out. But in this case, the angle is really stupid. So I will either need to take this end plate off to access the drive circuit, or just take the whole board out, which is kind of effort for a small drive circuit issue like this. Nah, screw it. You know what? Let's take the whole board out, because then I can sort that capacitor out as well. Taramps says to individually charge each battery. That sucks. That's long. Mad says it does build rail voltage when pulsing the remote. Can the issue be related to bad overheated rail caps? Nope, nothing to do with your rail caps, my friend. It's nothing to do with rail caps in the slightest. The voltage value flickers when wobbling one of the rail caps. That does suggest that there might be a poor solder joint somewhere on the PCB, because the rail caps are massy and they have leverage over the PCB. So those amps are all surface mount stuff, and you can get bad solder joints and cracks at the resistors and stuff. So it's going to be hard for you to find with your eye, with the naked eye. So if I was in that scenario, in that situation, I would go over it very carefully, looking very, very closely, and I'd probably just go with the soldering iron and reflow loads and loads of the surface mount solder connections for a bunch of resistors and stuff like that around the drive circuitry. Any that look like they could be lacking a bit of solder or have a little crack hairline in them or something like that, and go from there. Nick says, I just installed a new head unit in my 2020 Corolla with JBL system. I added, oh shit, I dropped him this screw. I just added a sub and the JBL speakers cut out randomly at idle until I start driving around. Is that while you're playing the sub? If that's the case, then your issue is voltage drop. Oh, you must have a voltmeter hooked up at the dashboard, so you can see it, and the voltmeter must be connected to the amplifier power terminals. So you need a long wire from the back to the front for the voltmeter, and you need to make sure that the voltage isn't dropping below 12 volts. If you see 11 point anything, then that's problems, and you need to make changes to your wiring, ground point connection, power fuse point connection quality, upgraded battery, better wires, something like that. The reason your mids is cutting out is because the amplifier that the mids is running on, or the head unit, is below its threshold voltage for powering on. So it's going into protect and then it's coming back on. And the reason that it works when you drive around is because when you're driving around, the alternator is generating a lot more current while it's spinning faster, while your engine's revving higher, so therefore it's kind of negating and giving a bit more voltage to the system. But while you're sitting idle, it's actually the alternator doesn't really generate that much current while it's sitting idle. So yeah, you need to sort out your power supply there, my friend. How does one determine if the power transformer of an amp is near its limit with regards to oscillation frequency? You'll start getting excessive current draw. So if you're playing around with the switching frequency of a transformer, as you increase it, monitor the idle current, and there'll become a point when the idle current sort of is staying the same, and then it will suddenly start increasing. The idle current will start getting higher and higher, at which point you know that you've reached the limits of that transformer. I'm just looking at this rail cap now. Actually, it's wobbly. It looks really interesting the way that this has been soldered. I don't know. It looks like there's been some sparks or arcing or something. The way that this has been cut, yeah, very interesting. Nothing on the back of the heatsink here, but I'll zoom in a little bit so you can see the rail caps soldering here. So it kind of looks a bit like, I don't know, there's this sort of bit there that looks like it's not really soldered that well, which is weird, and sort of similar on the other one. Weird. Right, let's just solder the capacitor in better first. Stop it wobbling around. Dreo says, wish I could send a picture of my workbench too. You can actually. People have sent me pictures before, but I don't have my email address on the description anymore. But if you want to, you can send me a picture of what you're up to nsvaudio, all one word, N for November, svaudio@gmail.com. If you want to send me a picture of what you're up to, we'll have a quick look. You have to obviously be comfortable with your picture being shared on stream, so don't send anything in that you wouldn't want the internet to see. Okay, that's better. The capacitor is now sitting down a lot closer to the board, just kind of walking it down as close as possible. There we go. Let's check the other one as well. The other one's fine. Alright. So, output drive circuit fault then, potentially. What's kind of annoying is this wire here to the heatsink. So I'm actually just going to desolder that for a minute. Guys, remember white is positive. And I'll solder that back on later. So let's take a look at the driver card and let's see whether there's any obvious poor solder connections or anything like that on here. So we might have a defective 2092 driver, but it could also be bad solder. So I'm looking at the screen with you here, guys, which is kind of hard, but I'm just going to let you see that for a minute. And then I'm going to take a look with my eyes as well. See if we can see anything that doesn't look too greatly soldered, etc. Okay. Yeah, that looks okay. Got the so the bootstrap circuit. I'm just trying to see whether it's on the main board or whether it's on the driver card. Looks like we have this diode here might be the bootstrap pump, because I think this second to last pin and this fourth pin along here might be the high side supply and high side ground, possibly. Although actually no, it could be these two. This could be the bootstrap pump diode, or either of these two, and this could be the capacitor for it, maybe. Well, thanks Mads for the 100 DK, Danish kroners possibly. That makes sense since the issue came from just sitting on the shelf. Thanks you for always being so kind, you're a great mentor. Thanks man, I appreciate the compliments there. I hope that you get your amp sorted. I have a Paris 1 ohm 3500, how do I contact you for a repair? If you're in the UK you can message me on Bearvid's Facebook page, facebook.com/Bearvid, send me a message. And if you're in the UK, then I can help. If you're not, then unfortunately you need to find a technician in your country. So yeah, like I said, I'm not really seeing any obvious poor solder joints or anything like that. So I think the first thing I might do is I'll have a little probe around with the 2092 on the oscilloscope. I might just change the 2092 because you can just get a bad one. I'm just going to check that none of these diodes are shorted or anything like that. That seems alright there. This one. Yeah. Yep, seems fine. Let's just power it up, and we're going to have a little probe around on the 2092. Check its supply voltages and all that jazz. So I'm going to turn the voltage down a touch. Negative rail. Let's see, where's negative rail? Be on one of these FETs probably. Okay, negative rail, we've got 47 volts. So the supply for the 2092, I can't remember what the supply pin is, I might need to get the data sheet up. Let me just grab the data sheet for that. iOS 2092S. Okay, VCC pin 12. So pin 12, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, that's here. .34, yeah, that's about 12 volts above negative rail. On the scope screen there you can see. 34 volts VCC. Okay. And have a quick look at the data sheet again. VA and GND, 3 input CSD, that's going to be fine. COM, low output, dead time. I'm just going to check VAA and also in. Try and do this in a way that you can see. Okay, we've got 5 volts on VAA, that's fine. Don't have anything on pin 3 in. But that's fine because we usually have an audio wave there, so yeah, I'm going to go ahead and take a stab that the 2092 itself is a faulty, so we're going to replace that and see how it goes from there. What do you think of the in-phase amps? Yeah, the in-phase amps, not like I say, not bad value for money. Pretty good for the price. It's an older circuit, mass-produced older circuit, but not too bad for the money. Just keep them well away from vibration. Don't mount them to your box because they do have weaknesses against vibration damage. So. Yeah, one of them needed a couple more rectifiers. There's some like minor circuit design choice issues that I would change, but they're not too bad. Constantin says there's a cracked solder joint in the middle of the board on the back side of one of those big pads. Not sure what you mean, or whether you're starting the stream early and you're looking at something else that we did earlier. Oh, actually, you could be talking about on the back of the main PCB. Let's just do a quick, one last little visual inspection of the back of the main PCB. And have a look, just see if there's anything else going on the main board. So all of the main big solder joints for the transformers here look okay. Got the inductors here, look fine. Doesn't look like any cracked solder connections on any of the FETs or rectifiers here. Voltage regulators look okay. Yeah, everything else seems to be okay on the back of the main board, so. Right, let's find us a new 2092, drop that in and see if that solves it. 2092s, there we go. Afternoon, Darktron, how's it going, buddy? Yeah, day's going pretty good, man. Thank you very much. Hope yours is going okay as well. The angle is very tricky on this one, especially to keep it in camera as well. I might just have to sacrifice it not being in camera just to do this one for a sec. I'll put you on the head cam. Will I put you on the hat cam? Maybe, maybe not, depending on whether it unfreezes or not. There we go. So yeah, this will have to be a view for now, just because it's kind of blocked on this one. Definitely not my straightest chip solder, but these amps are for evaluation. I don't really think they're going to be resold anyway. It's a little bit on the piss. It is a little bit sideways. It's not dead straight, but it is all soldered like correctly. So do for now. Let's just see if that made a difference, giving us our Class D switching or not. So let's probe low side drain. See what it does. Oh, okay, no, we've just got a massive swing to negative rail now. Interesting, okay. I'm just wondering whether it got a bit overcooked or whether that was just a bad chip, because that chip that I dropped in was a used one. These amps are for evaluation to find out why they failed and to report back, not necessarily for resale or for any customer repair. So just thought I'd use up a used 2092 that I had in my drawer that's supposed to be, they're supposed to be known working ones, but that one might have just slipped through the net. Alright, let's just grab a brand new 2092 screw it, just to be sure. This is a brand spanking new one, this one. And I might actually just tack this one in with the iron on a couple of legs first, just to hold it still. Because this angle that I'm doing this at's really awkward, so you can see it on the camera. Oh, the things I do for you guys. There we go. So I've just tacked it in on a couple of legs, so now when I heat it, it should sort of like just sink perfectly into position. There we go. I wish you'd have seen that, it just kind of like sank down beautifully. Are all the legs soldered? Or did it even not quite get hot enough? Let's have a look. Couple there that might be, but they also might not. So I'm just going to go over them with the iron for a sec. Someone keeps saying, look at the pin behind the cap. You just solder blob on the contact. Someone says, look at the pin behind the cap. Which capacitor? On the driver card? Do you mean this pin here? That definitely does have solder in it. That's not disconnected. Yeah, that's fully soldered from the back and it has a via, so that's not a problem, my man. Okay, let's hit the power, see what that does. Right, so we're still getting this glitching. So it's still unable to build Class D switching. So it's not the drive I see. Okay, this could be an interesting one. So the next thing that I feel like that could be is maybe the high side. Hang on a minute. Put that in there. This could be the high side bootstrap diode, possibly. This could be a tricky one to diagnose, actually, guys. Right, let's just run some continuity checks. So from low side drain, we should have continuity to, we check on the data sheet here. Low side drain, we should have continuity to VS, which is pin 13, which is fourth from the top. So let's put our multimeter on low side drain. Okay, yeah, we have continuity there. Then we should have a diode. Don't know what that is. Should have a diode between VS and VB. With a capacitor between VCC and VB. Sorry, a capacitor between VS and VB, but a diode between VCC and VB. Alright, let's have a look. So the capacitor between here, let's have a look, which one's that? That looks like it might be this one. Yep, so this is the capacitor between these two. The high side supply and high side return. Now the diode between VCC, so this one and this. Okay, so this is the bootstrap diode, bootstrap capacitor. So we could check that. We could pull those and check them. And let's probe and see whether we're getting actually bootstrap supply, which is kind of difficult because it only really appears when switching starts taking place. So maybe I can use both of my probes here and that will tell us. If I go across the capacitor, that will work, won't it? Okay, there we go. Okay. So we've got 15 volts on. Got 15 volts on VB. $15 volts DC on VB. I don't think that's supposed to be there. I'm not used to seeing that. this is the '9701. Do I have another one of those? I have a 2041 one. I was just seeing if I had another one of these amps identical that I could just probe the drive circuit of and just get a reference of where the voltages are supposed to be. What's up, Matt? How's it going, Matthew? You ever thought of getting into other aspects of electronics repair? Possibly. Graphics cards are a bit of a hit and miss one though, because sometimes it can just be a dead GPU unit, like the actual die itself, or they are like super multi-layer PCBs, which can be really headaches if you've got broken traces in the multi-layers. And I know you've seen people repair them on YouTube. It just looks like a lot of time and effort. I'd have to charge quite a lot of money if I was doing that kind of thing. So possibly in the future, but not just yet, but maybe. Legit skills? I would say the lithium battery amp power is less of an issue than the internal resistance. The internal resistance of the battery bank is most important, so depending on your impedance rise, possibly, but the only way that you can know that for sure is by setting it up and seeing what your voltage drop is across the range. I can't guess, because too much of it depends on the impedance rise, efficiency of your woofers, etc., what enclosure you're using, stuff like that, so it's very difficult to say. Okay. So we're getting 15 volts on VB. Let's have a look at this again. This is just a typical connection diagram, which is probably what they're going to be using in this amplifier. They're not really going to stray much from the typical connection diagram. So VB, we have capacitor from VS, so that's no DC coming in from there. We have diode from VCC, that's negative rail reference, that's not coming from there either. We have resistor between CSH, that's overcurrent shutdown, I believe. We have a diode from B+. So if that diode is leaking from positive rail, then that might be sending 5 volts or 15 volts through to VB. We also have a connection from a resistor through to the source, I think, on the high side FET. Yeah. No. I don't know. Let's have a look at this one again then. So the diode that's got positive rail on it, let's have a look, is that this one? Oh yes, possibly. Let's just wait for the rails to sink back down again, go from there. How's it going, Stefan? for a fun experimental stream, sometime you could buy a couple of really cheap broken electronics like computer parts, consoles, etc., and try and fix them. Could do. Problem is, my audience is mostly audio based, so when I've done fixing other stuff in the past, like a Nintendo Switch console, etc., the viewership was pretty low. Hertz EP4, the repair costs much more than a new digital one. I doubt it. Depends where you're getting it repaired, but shouldn't really do. Those are pretty easy to fix. Shouldn't be that expensive. Okay. I'm just going to check continuity from this pin here, which we've got 15 volts on. I don't really believe that that's correct, but it also could be. I'm not sure. So got that resistor there, continuity, that diode, these two R2s. I can check those. Six, 8, 1. I wonder what IC1 here is doing. We have continuity from this VB to pins, what's possibly 7 and 8 of this IC. Okay, interesting. Should be a 20 ohm, 4R7, 2.2, 2.2, 2.2. So what's wrong with this amp? Not Class D switching is failing to initialize, but I'm not sure what's actually wrong with it yet. We've changed to 2092 and that hasn't helped. Right, we've got positive rail here on this one, this 1502. Yeah, the multimeter's not showing. It keeps like the USB keeps disconnecting, so I've kind of given up with it for now. I need to cut the end off and solder a new USB connector on, but I haven't got around to doing that yet. Right, where to go from here? Don't really think I've seen this type of issue before on a 2092 driver. I want to know what this is. This is a 103 NPK. What is that? NPNPNP, high power double bipolar transistor. So, are these driving the FETs, and it's not the 2092 driving the FET directly then? So pins 7 and 8 were connected, which makes sense because they're the same thing. 5 and 6 are C2. 4 is base TR1. So we've got double collectors, single emitter, single base. Okay. So let's see whether they're driving the FETs and it's not the 2092 driving them. So let's probe the gate resistor here to R2. So we come into the driver card here for this one. So we do have a direct connection. 35. Hang on. So we've got 2.2 ohms there to here, to this input, this pin of the driver card here. But then I'm not seeing a direct connection to the 2092. We do have, actually this, whatever this transistor is, looks fucked. We've got connections to basically all of the pins. Okay, yeah, these look like the drivers. Weird, not seen this kind of setup before. We've got the same thing going on this one. So we've got a 20 ohm resistor here. That looks like it's between, if I just turn this onto resistance setting instead. 25. So this resistor here is between this pair and this pair. With a 4R7 in series as well, so it's like 25. So it looks like we've got a 4, here we go. That's a direct connection. Then we've got 20 ohms that side, 20 ohms that side, and then 25. And then on this one, we should have the same. 25. This is a mega weird setup here. Right, just as a kind of new troubleshooting method real quick, I'm going to power the amplifier up, and while it's powered up, I'm just going to run the hot air gun across the driver card on a lower heat and just see if at any point the attempts at building Class D switching change. Either they get better, get worse, etc. That might help me pinpoint where what the area of the issue is. So get this powered up and attempting to switch. Here we go, like this. So I'm just going to run some heat over the driver card. No, nothing seems to be changing on that. Yeah, this is mega weird. I'm sure this 15 volts DC on VB isn't right. Maybe it is, but yeah, maybe it is. I'm sure that that's only supposed to be there when the Class D switching initializes, because it uses the pulses to pump the voltage. Weird. Let's have another look at the main board here. So I'll make sure these inductors are not shorting or anything. Right. Looks okay there. Looks okay there. Let's just go and check some resistances on this card real quick. So we want a 680 down here. Yep, that's good. We've checked that all these drive transistor ones are okay over this side. This is a 5602. Let's check that. Unfortunately, I have power in the board still, so it's not really able to read it. Power spiked to 0.8 when touching the driver card. Let's just see that again, see if that is repeatable or not. No. Okay, weird one. I would love to speed up this repair by grabbing a known working one of these and just comparing voltages, because that would massively help, rather than pulling every part and trying to figure out what's wrong. I imagine it's going to be a semiconductor part on this driver card. It's going to be one of these diodes or something along here. Yeah, I just want to see whether that 15 volts is actually there. Have we done one of these before? This is the, what is this? 9701. I'm sure we done one that was very similar the other day, didn't we? We did an 8701, 9704. We haven't done a 9701 yet. Right, what I'm going to do, guys, I'm just going to put this to one side for a bit. I'm going to see whether we have one that uses the same output driver card, just to take some voltage references from. I've not actually seen this exact driver card before, so I don't know where the voltages should be on it, but we'll figure it out. So what's this? This is a 1404. Oh, this one says working, so I guess that's fine. That will just be an evaluation one. That's a 4-channel 1000 watts. I'll look at that some other time, just to see whether there's any circuit design things that could be changed. This is the 22041. This is going to be a 4-channel class D. No input RCAs. Are they missing? Thing is, Frank, is that the 2092 driver doesn't use PWM input, it uses audio input, and it generates the PWM itself, so that wouldn't really help in this case, unfortunately. Oh yeah, here we go, the RCAs. RCA is just missing on this one. This is a really easy fix. All I've got to do is just grab one of these RCA rings on the ground and just shove it in. Don't have another black ring spare, so what I'm going to do is I'm going to give it a white one. There we go. New RCA fitted. That's not coming back out again without a pair of pliers. So let's just check that this powers on and works on all channels. Okay, power on, a little bit of RCA signal. Let's see what we got. Line input. Let's turn everything to full input mode 2 channel so we get everything on the outputs as well, just from front. Level down at about 3rd. Bass, super bass. No thank you. Okay, cool. Let's power up and see what this one does. Hard for him to get a good connection to the remote wire. That might explain why. Do you not solder the ring on the back side? No, these ones aren't soldered. Okay, so we've got nice clean sine wave on this channel, and nice clean on that, and how about the others? Nothing on the others. I should be in 2-channel mode. Ah, 4-channel. Oh, that's interesting. That's interesting. This switch is backwards. Ah, that's something interesting. Right. So guys, there's a switch on the side of this amplifier that's called 2-channel mode or 4-channel mode. So when the switch is in 2-channel mode, you can input RCAs into only the front channels, and it will also duplicate that signal for the rear channels. But when you flick it to 4-channel mode, you get separate inputs for front and rear. However, on this one, that operation is reversed. When the amp's in 2-channel mode, we only have output on the channels, on the front channels that we actually have it connected into. But when we flick it to 4-channel, it duplicates it onto all of the outputs. So although it's not really a fault, it's the switch has been put on the wrong way round. So yeah, I guess I should open this to sort that out. But if I do so, I'll break the warranty seal. So I'm going to go in via the side and do it from the side panel, just so that we keep the warranty sticker intact. It means that this amp could be resold if need be. Hey Danelle, how's it going, man? It's a two-way switch, and I can tell you now that this switch can definitely be put backwards. It's symmetrical. You can screw it in upside down, and yeah, it'll not work how you intend it to. It's not the silk screening on the panel. We can just flip the switch over, because look, I'll show you why. So you see this switch, it's actually not soldered to the board. Okay, this switch is just hanging on the panel. Okay, so that can just be flipped upside down. You understand? It's been put on upside down. So all we've got to do is just unscrew it from the side panel and flip it around. But I do agree with you that yes, if this was a soldered switch, then yeah, it couldn't really have been installed upside down, because obviously then the pins wouldn't go through the board. So let's flip it upside down. There we go. And screw it back on. Are you the amp repair guy for InPhase now? Pretty much, yeah. I'm doing all their warranty repairs. I wonder, that makes me wonder actually how many of these amps have this switch backwards. It seems like pretty easy to do given that it's panel mount. There's possibly a whole batch of these like this. It's not a big problem as long as you notice it, and because the issue with that is that you'll end up trying to use this amplifier in 4-channel mode, and so you'll be feeding separate RC inputs to, you know, the front and rear inputs, but actually it'll only be listening to your front inputs, and your rears will be completely ignored because it'll be cloning your fronts when it's on 4-channel mode, and you won't necessarily know that. Jack the Ripper, how's it going, man? Haven't been around in a while. Even now, just popping in and out. Take care. Thank you very much, man. Appreciate you. What's your views on JP amplifiers? I haven't seen any in person, so it's very difficult to comment because we don't get them in the UK. So, did you miss anything worth looking at? I would take a look at the first amplifier, the Juice. Look at the fault with that one. Really funny. Then I've got a 9701 here that's actually giving me a bit of grief. I've got a drive circuit fault, and the driver card isn't one that I've already seen before. It's got a 2092, and usually they're pretty straightforward. This one's struggling to build Class D switching, and not quite sure why yet, because I'm not familiar with all the voltages on this driver card where they should be. So I'm going to try and grab one that uses the same driver card from the van and take some reference voltages and whatnot from there and see if we can get it working. What's up, Daniel? How's it going, man? Yeah, so that will now be the correct operational mode of that switch. Excellent stuff. Yeah, schematics are cool. However, in this instance, I don't think the schematics will come in super handy, because with this kind of fault, the schematics won't really tell me what the fault is. Like I know where everything's connected to, but I'm just not sure what part it's not happy with. It might be worth a look anyway, but I don't know, Donnell, whether InPhase would want the schematics being shared live on YouTube. Yeah, probably not. Yeah, I didn't think so. Okay, the last one we've got here is the IPA 1000 2-channel. Says blowing fuses, internal short. That will be a power supply fault, I'm sure. Possibly an output side fault if the fuses blow when you try and power it up. So let's get this one opened up and see what's going on inside. Okay, single-sided PCB. Class AB actually, this one. Nice and basic circuit we've got here. TF104. Power supply FETs here and here. Rectifier diodes here, outputs here. So let's check the outputs for shorts first. Nothing there. Nothing there. Okay, let's check the power supply FETs for shorts. Nope. Nope, it's just charging the cap. Okay, interesting. So no power supply shorts on this one, or output shorts. So why is it blowing fuses? So let's get a fuse in it. There are fuses in it already, and they are intact. Maybe the wrong sticker got put on this box. Okay, let's see if it pops a fuse or not. Well, it won't pop a fuse, but it will just draw excessive current. So no excessive current drawn yet without power up. Let's get it. I'm pretty sure this is going to work just fine. I reckon that the wrong sticker got put on this box. RCA input. This one has damaged RCA inputs. That might have been what's wrong with this one, and not the fact that it was blowing fuses. So let's just quickly sort that out before we go any further. I'm going to use red and white on these. Left as white and right as red. Okay, that one's a bit too loose, so we might just need to make some adjustments to the shape. That's better, nice and tight. And this next one. There's our right one. That's a bit looser than I'd like. Yeah, it's a bit looser than I'd like, so let's try a different one. Hopefully with a bit sharper spikes on it. That's a bit better. Okay, let's roll with that. How do you have so many parts inventory already? Well, I've been doing this for like 6 or 8 years, so you accumulate bits and pieces. So crossover full, level, down at minimum, subsonic, minimum, bass boost. Bass boost was maxed out as you'd expect. Low pass filter was maxed out. Everything was basically maxed out. It's typical. Okay, powers up. Nice sine wave on both channels. So yeah, this one wasn't a blowing fuses. This one was just a RCA issue. So wrong sticker on this box, but that's fine. Right, that is, apart from, I was going to say that's all the in-phase amps that I've got, apart from two of their biggest ones. I've got two of the massive, I think they're 5,000 watt RMS jobs. They're just basically a Korean half-bridge circuit built in China. But I want to get this 9701 running with the 2092 with drive circuit fault issue, so I might go and have a quick peek in my van and see if one of the others has a similar drive circuit setup, and we can probe the drive circuit of that. Or maybe we'll do that on another stream. What is it, 8:30? Yeah, I don't know. I would like to get that one up and running this evening though. But guys, I'll leave it up to you. The choice is either go and find an amplifier that uses the same drive circuit as the 9701 that we were struggling with a little bit, or start having a look at I've got two of the in-phase 5K RMS big boys, and I can have a look at those instead. You want to look at the 5K? Alright, we'll look at the 5K. This box, for some reason, has like 3 bass controllers in it. Oh no, it just has one. It has the wire for the bass controller, but actually not the bass controller itself. Okay. Okay, let me grab one of the 5Ks then. I might need to unplug my camera for a sec. My bad, sorry, I unplugged my mic there. Alright, let's start that again. So, just before we get the 5K out, let's have a look at this guy's workbench. So this is Dreo's workbench on the live chat. So it looks like we've got a little cheaper amplifier here. Class AB, possibly Class D. We've got some surface mount components on the back here, which is pretty interesting. We have the Stanley knife. I'm not a fan of these because they tend to push the blade back in when you push too hard on them. Kind of annoying. You know, we're trying to get something tough on that. The toothbrush. My man, you always got to have a toothbrush on the always got to have a toothbrush on the workbench. Love to see it. We have the auto range multimeter. Not a fan of the auto range myself. Just seems to take longer to decide what the reading is compared to a manual range meter. We have the electric screwdriver, which I personally wouldn't use. I like to feel the torque. Looks like I've got some flux in there, some solder wick. Nice, love to see it. The variable controlled temperature soldering station. Yeah, looks alright. I'm sure that'll do a good job. But that is also the hot air station as well. Yeah, nice, love to see it. A lighter. Maybe this guy's puffing the old ciggies. The old backy. A few donor boards possibly, or other repairs. Really, really cheap Class AB nasty stuff here. Possibly some canned air. Got some water. Got to stay hydrated. Got the sellotape. Got some keys. Is that a car key? That's a Seat. My man's driving a Seat right here with some old Chubb keys as well there for the house. Got the standard keyboard. That's a lot cleaner keyboard than mine, I have to say. Some more syringes, circuit board bits over here, wires, more circuit board stuff over here. That looks like maybe an MP3 player over there. Calculator perhaps? Oh, it's a Suzuki, not a Seat. My bad, that's a Suzuki. That is a Suzuki. I would fail the test at the vehicle logos. What's the Seat logo then? Maybe the Seat logo is more square? That's a Suzuki logo. That could be a Suzuki Swift or something like that. What have we got on the back here? Some pliers, got a screen, got some screwdriver bits. Can't really make out the rest of it. Got some, maybe some tapes up here. What's this? High-res audio boombox. That looks like there's a speaker in the cardboard box here. Do you see that? What's that all about? Is that my guy's test speaker? Maybe he's put a speaker in a cardboard box as a test speaker. Yeah, look, looks like it's hooked up here to the speaker terminals. Looks like my guy's using a cardboard speaker box. Okay, that's pretty interesting. Nice and lightweight for throwing on the workbench. A few more bottles for hydration. Yeah, it's messy but usable, I guess. Is that a relay? What's this? My guy's got the OXO cube up in here. What's this? I'm not sure what this thing is here. But yeah, thanks for sharing your workbench with me, guy. Appreciate that. Adrian, yes, sent you an email. Yeah, Adrian, I've got your emails just now. I haven't actually checked the NSV inbox in a long time. That was the first time I've checked it in weeks. So I've just seen a couple of emails through from you there. Thanks for the 10, Adrian. Appreciate you. Yeah, I'll shoot you a response probably after the stream if I remember. Okay, so yes, 5K. Let's jump on the 5K, one sec. So the email address for sending something in, if you want me to have a look, is nsvaudio@gmail.com. nsvaudio@gmail.com. Send me a picture of what you're up to if you want, and if you're happy for everything in the picture to be broadcast live to the internet. Let's get this back up and running, this hat cam. Okay, the chunky boy. These don't have rear case or side plates, unfortunately, but that's okay. What's going on here then with this one? Whoa, that got really juddery there for a sec. Okay, so this is your typical Korean origin Class D subwoofer amplifier, but this one's probably made in China. We have lots and lots of board flex on these. They do suffer from vibration damage quite badly. We've got quad IRS 21844S drivers, FDA 24N40 output FETs, pretty standard. Power supply 494-064Ns. So yeah, let's have a look. This is probably in Protect because it's got dead output FETs, which these like to do. So we've got a short there, and that'll be because there's a dead FET somewhere in this bank. So let's carry on and see if we can find the short. Okay, there's a short there. So let's cut that one out. This one looks like it's got super hot actually at some point. Okay. I see why this amp has failed. I will show you guys momentarily. Just going to find the rest of the shorted FETs if there is any. Could just be one. How about over this side? Any over this side? Oh yes, there's going to be one somewhere over this side. There's one over this side as well. There's another one. Okay. Okay, there's going to be another one somewhere. Either another one or the drive circuit's dead. I think this one might be shorted. So look, 212, 190, 212. Yeah, so it's the one that's 190 is dead. That one there. Okay, that's better. It's better. Okay, this one might be dead. 231. No, I think the driver's dead actually in this one, because if we measure after the gate resistor, we get a lower resistance. So that means the driver's dead on this side. Okay, so we've got lots of dead MOSFETs. We've got a dead driver on this side. And the reason I know that is because we're reading 230 ohms here. And after the gate resistor, the resistance drops to 187. So that means we know that it's the drive IC that's causing that low resistance. On this side, we might have a similar situation going on over here as well. Okay, so yeah, full output circuit rebuild, full output section rebuild on this one. Now the reason, guys, that this one failed, if we take a look, I've already seen why. It's the same reason that most of these in-phase amps fail. I'll try and get in with my hat, it might be a bit easier here. Actually, I can take the camera off, can't I? Yeah, awesome. Oh, this is great. Let's take the camera off. Right, guys. So this here is one of the rails that passes probably rail voltage up to this side of the amplifier, and this is just loose. So vibration damage once again, just due to sort of slightly poor assembly, has caused that to fail. Was no longer making an electrical connection, and it has caused the output section to fail. So what I'm going to do is first of all resolder that, and then we'll have to repair the output section, but I might leave that for another stream. Might do a stream of its own. So there's quite a lot of thermal mass around here, so we've just got to wait for that all to sink in. There we go, it's starting to go. Slowly but surely. There we go. Much better. Soldered in, nice and deep on this hole now as well. Should prevent that from happening too quickly again in the future. And we want to go around all the rest of these as well, because they don't look too great either. That's why this output section failed. Yeah, just vibration damage. And it's going to probably need at least 1 or 2 new drive ICs on here. Oh yeah, a couple of drive ICs, but looks like we've got a couple of them have holes in. All new output FETs, and possibly high side current resistors as well. Okay, that's better for that one. So yeah, interesting stuff. So guys, thanks for joining. I think we're going to lock it off there. Interesting stream. We've got some bits and bobs to sort out on the next stream. I want to figure out why the 7901 is having a drive circuit fault, and figure out, learn those drive circuits a bit better, those driver boards a bit better, find out where the voltages are supposed to be, and also get these 5Ks up and running. So yeah, full output section rebuild on one of these, and it's probably a similar issue on the other one as well. So hope you enjoyed. Thanks for everyone for joining. Massive thanks to anyone that donated. That's really, really kind of you. Hope you enjoyed. Have a great rest of your Saturday, and I'll see you in the next one. Take it easy, guys.